Welcome to a new CGP video by Nyjo FX. Today I'd like to show you something about LiquiGen. As you know, JangaFX just released the first public alpha version. It is essentially a pre-alpha version. It is available just for the users with a suite license. By the way, it is a really early release, so you know there are really not so much feature. We are waiting to have more and more feature coming in coming weeks, and it is obviously just the initial build we can use, but I think it is amazing. As always for the JangaFX, you know, the suite is based on EmberGen, GeoGen, and now LiquiGen. We was waiting for a lot of time about LiquiGen. It is a GPU fluid simulator about liquids. So we have explosion and pyro effects and gases effects with EmberGen. We have terrain and planets with GeoGen, and now we have liquids with LiquiGen. By the way, let's start. You see the user interface is similar to the other tools, so it is simple to move from one software to the other one. You can start using presets, for example, or you can start creating a new scene from scratch. So today, that's just you know, an impression video, first impression video, so it is just to see how it works. So if you like, for example, you can pick something here. Let's say, okay, let's use, for example, I don't know, for example, this one. It is loading, and then you see it is starting. And I think that's amazing. It is playing and simulating and meshing in real time. So that's really amazing. I'm using the software over an RTX 3090, so it's not the fastest GPU you can use today. By the way, I think that's amazing. We have the simulator, we have a path tracer too, so we can render with a path tracer, and we have another the standard visualizer. So again, we are waiting for a lot of feature coming in the future build, but we can start playing with the software. That's really nice. You see we have the UI is the same as we saw in EmberGen and GeoGen, so you can use it in a really simple way. We can go to see more stuff. Let's see, for example, glass of water. Don't save. It is compiling the shader, so actually it is starting to simulate, but it needs time. So this one is with a path tracer activated. So you see we have the path tracer and the photo mapping. So we have the a lot of effects because with photo mapping we can have, for example, the caustics, and everything is done in real time. This thing, for example, is not so fast over my GPU, but you know, you can play with the values there, the parameters, to have something more something faster. But again, you see it is working in real time, and we have also the caustics, and this one is rendered in a better way, as you can see. So if I go to stop the simulation, it will take a little bit of time to have a really precise rendering. We have also a denoiser, so that's really nice. Let's go to say, for example, that we like to have just 20 sample. It is going to be obviously faster than before. So you can take care about the speed, is not a problem. You can, for example, deactivate the path tracer and go back to the standard render. You have the possibility to use the lights as the other tools, the colliders, emitters, and forces. You can export and import stuff from the software. So that's really, really nice, I have to say. It is essential right now because, you know, we have not so much feature, but it works. So let's go to see what's going on this one. It is going to to be really slow, this one, as you can see. So maybe it is better to go for something more simple. Let's remove the path tracer and let's see. Okay, I think maximum amount of particles has been reached. So I think we have to do something, and they say it is possible to increase the limit in the simulation node. So max particles, that's this one. By the way, we can, for example, use less particles. So it is obviously more simple, but it works. Obviously, if we go there, let's say we like to have maximum 50 million particles, and then we go back, because it is spaced, so if you rise up with the resolution, you can achieve something better, and you see that that's really amazing. You can decide, for example, to see or not see the liquid mesh, but maybe just the points. Then we can go back here and say to have back the path tracer, and obviously it is slower than before, but it is working in a really nice way. Let's remove the point. Let's go back to the liquid mesh. Obviously the liquid mesh is visible in the path tracer, so I think they have to adjust some stuff, but that's really nice. So that's the collider. Now we have the appearance node. The appearance node is something similar to a shader, a material, okay? So here, for example, we can decide the watercolor. So this one is going to change the watercolor, for example, and then we can decide if we like to have the refraction, if we like to have the reflection, and stuff like that. Let's say that the transmission is a different color. You see that the water is changing the color, and then we have an higher value for the transmission. So you can play in a really nice way with this one. You see that we have the refraction. So actually it is simple. You see that, for example, we have the roughness, and you have the possibility to create also metals. By the way, that's really nice, I have to say. So I was playing. The first thing I tried to do, it was really simple, because I was trying to see how the forces are playing and stuff like that. And we can see something there. We go in the home. It is called just test, because it was really simple. Don't save, and I like to stop, because I like to play with the scene with you in real time. First of all, I like to go back to have no path tracer for the moment. I like to go back to have this force, and this one is deactivated. The scene is really simple, so I have just to move some stuff. So this one is not usable because it is not needed. We have the forces here. That's the appearance for the liquid. That's another force. This one is the emitter, and this one is another force. Okay, so the scene was created just essentially creating a new scene. So that's what we can achieve using a new scene. So I like to create a new appearance. So we are going to use the standard one just to show you how it works. Okay, we'll have no turbulence, no drag, no turbulence, just a constant, and we'll have no force there. Let's remove this one, and we have just the emitter, and we can remove also this one. So essentially this one is the scene we have at the beginning when we say we like to have a new scene. So as you can see, we have this kind of emitter. By the way, we add an animation there, so let's remove for the moment the animation. No, maybe it's better to use another emitter, so we have no emission, no animation for the moment. So let's go there, and let's say that this one is the emitter and this one is set to off. Okay, this one is continuous, and let's say that we don't need to have the mesh. Sorry, we are in the, let's go to points, and let's move this one. So we have just the particles. Okay, you see, that's essentially the emission. But when the scene is set as default at the beginning, we have a force, the constant. The constant is essentially a constant. It can be something like, you know, the gravity, or maybe it can be something like wind. So, sorry. If we go there and we go to create another one, so we have the default one with no animation. That's the standard one. So the fluids will falls down. Okay. And you see everything is working in real time, and that's amazing. Really amazing. So there is a mesh called the drain, and the drain is able to you know, to make the simulation just there, because the other particles are erased, because this one is a space volume, so it will continue. There is no volume, and it will continue to simulate and expand. So that's why we are going to use the drain. It is something new for LiquiGen. Maybe we'll have the same in the future in EmberGen, using the space when we have the space simulator. So we have this one to stop the simulation outside. And the nice thing is that, you know, it is working. That's the collider. It is working in real time. So you see, everything is working in real time. That's amazing. We have nothing like that. Obviously, again, that's the first version. I mean, it is not a version. That's the first public build. So it will need time to have a really complete software, but it is really amazing. Let's go to have an HDR map. It is loaded from my workstation, and with this one we have a better illumination. Okay, so I made something really nice. I think it was just to play with the software. So the first thing was to have some kind of turbulence, you know. I have two turbulence. One is bigger and the other one is smaller, but we have you see animation just for the emission, and then we have just the animation for the force and the other shape. So I like to show you what's going on. First thing is to have this one. Okay, this one is a force shape, so it's an abstraction, so we can abstract stuff. So let's say that we have our, so let's go directly to see what I've done before. So this one, the force, there is the abstraction. This one I have to remember if this one is animated or not. By the way, let's see the simulation. It is falling down. And then now there we have the animation. So you see we are waiting for the frame. By the way, in the simulation we have the possibility to decide also the precision. You see that we have the sub-steps. Actually, that's really low, and we have just the basic parameters. I use just the voxel size to have more particles or less particles. So you see it's still falling down, and then when we are there, we have the animation for the constant, because it was used by me, and then we have also this one, and that's the force shape. So the fluids will be attracted by this one. Obviously now we have the fluids down the ground, so it is not sure, I'm not sure it will be able with the strength I'm using to rise up, but the idea was to create something, you know, like liquid metal, and you will see how it works. I was thinking about, you know, the Terminator, so the T-1000. This was done by liquid metal. So let's wait, and you know, we are simulating 1000 frames on the GPU in real time. So the abstraction is set to on, but I think it is actually not so much to rise up. So we can use my emitter. So this one is set to off and this one is set to on. It is working in a different way, and we can remove this one, so it's set to off, and we go to have my animation for the gravity. So it will work in a different way. You see that it's emitting and then it is moving, okay? But it is going away and then falls down because it needs to be played. So the first thing I done was to, let's remove the force. So now it is just an emission, you see, okay? I was creating a turbulence. So I set the scaling of the turbulence in this way to create this kind of movement. And I was using also a drag force. So you see it is moving, but now we have the dragging, so we have a little bit of forces over it. And then we have also this one. So you see we have a larger scale noise and a smaller scale. So this one is the large one and this one is the small one. So you see we are playing in a really nice way with the fluids, and that's really amazing. Okay, then the idea was to create the abstraction with the sphere. So you will see that we have the turbulence and then the shape, because the emitter is animated, so we have the emission of the particles just at the beginning, the fluids, and then you see that it's moving in a really fluid way, trying to shape the sphere. Then it falls down because we had an animation about the force, and then it is moving with a noise over the ground. But then we have something else, okay, because now it is moving in this way. And the second idea was to have another animation with another shape, okay. In this case we are talking about a sphere. And you know, actually it's not visible, but maybe it's just a temp issue. So we should have this one that is forming, morphing in the first sphere. Then we'll have the gravity that falls down, and then we should have the new forces there that is animated. So we'll set to on. Okay, it is starting to shape in this one, and that's really amazing. We can have, for example, this one there. You see that the force is in real time. That's really amazing. Okay, we have this one is the collider. It is not needed, by the way, we can use it. If we go to check the fluid mesh, and then we get to use my shader, is essentially something like a metallic material, a really simple metallic material. You see that we have this kind of fluid metal that is going to create this sphere. Then it falls down, and again, obviously the meshing is not so stable, but again, this one is the first meshing, so that's normal. And you see it's creating the sphere. Maybe we can use the second one. Maybe we can use another higher strength to achieve it. If we go to play with this one for the rendering with a path tracer, we have the appearance. You have to see which is the problem there. So sorry, I had to restart because it was essentially a problem to recompile the material. So again, the shader. So again, let's go back there. I go to change, and it seems working again. Okay, now it's metalness. Okay, it is working. Okay, nice. So if we go to play with it, you see that we have this kind of metal, this fluid. It is going to create the sphere. Obviously, again, you can use an higher resolution for the fluid, but it is just a test, so it is not needed. Let's go in the skybox. Let's light up the brightness. Okay. As always, you can render the image, you can export the mesh, you can do everything that is possible with EmberGen. So now you see that with the fluids falling down, and then it will rise up again to shape the sphere, the other force. Obviously the path tracer is a little bit slower on my GPU, by the way. It's really fast to see something like that. It is amazing, I have to say. You can just imagine what the team will develop for the final version of the upcoming version, because this one is really nice. And then you see that the fluid is moving up, attracted by the sphere. Amazing. Let's go to set off again the path tracer to be faster. Okay. So then I was playing with the import, because it's nice to see also what we can do with the importer. So I was trying to do something with our importer here using a mesh. And this one is a mesh we are using for a masterclass we are preparing. So we can essentially just remove the collider, so we have just the shape. So in this way, if we have this one, you see that it's trying to shape the dinosaurs. And that's really nice. Let's go to say that we like to have the ground. Okay. We can, for example, do something. Let's say that the constant, it's later, and the second force is not active. Okay. And the first one is a little bit higher. Okay. Let's go back. You see, it is shaping the dinosaurs in a faster way because the force is higher. And then when we'll have the dinosaurs, we'll have also the gravity. So in a few, everything will fall down. We can, for example, animate also the turbulence and the drag to have something that can become more stable, you know, to have something that is not completely moving. And then we have the liquids going down. Really nice. There is something that can be tweaked here to see why it is moving in this way. By the way, you know, we have to understand some stuff if our you know, bags, or maybe something that needs to be done in a different way here. Let's try to see if we have something with an higher resolution, so like this one, and maybe just a little bit higher substeps. It should be more precise, and we go to have the sphere emission there. You see that the fluids is moving from the ground in a more precise way. Maybe we can also, it is just a test because I didn't try to do something like that. So I can try to have another shape. Let's connect this one, and let's disconnect just for a moment the sphere. And this one will be not a sphere, but it is a box. Okay. And we say that the box is something like, let's say maybe 15 meters, 30 meters, okay? You know, something like the fluid is rising up from the ground. You see it is starting to rise up. For example, now it is stopping, so maybe something we can do is to have something smaller. Let's say we can move it here to see if we are able to create the dinosaur just starting from this area. Yeah, it is shaping starting from there. It will take just a little bit, obviously, to rise up over our mesh and create the dinosaurs. Maybe the fluid is not enough because the emitter will stop. But again, I have to say that that's amazing. You can create everything with this fluid simulation. Now it was just a test, you know, because I was thinking about the liquid metal, but you can create whatever you like. And I think it will be really nice to start playing with the software to create something, and it will be amazing to wait for the new feature they are developing at the moment. By the way, again, it is really great. Okay, so guys, that's all for the moment. I have to say that it's amazing. So let's see how it will move forward in the coming weeks and months, and how the final version will be able to achieve amazing effects like, you know, white water, bubbles, and stuff like that. More precise simulation, higher quality stuff. It will be really amazing to see. So, guys, again, thanks for watching. We'll see soon more feature about LiquiGen and the other software we are falling down with this one, I think, because we have not the constant. So actually, so then later it will force down. By the way, we'll see more stuff about LiquiGen in the future. So maybe we can have also some initial tutorial. By the way, you have to remember that this one is an alpha version, so stuff will change. We'll have different feature can works in a different way in the coming release. So it will be just to understand how the software works. So don't worry about it. Don't worry about understanding all the feature right now, because it is just an initial release. So let's wait just for the gravity, and then we can stop the video. We can make some tests in the future to see how the fluids can be exported in the other software like Unreal, or maybe Blender, or maybe 3ds Max and the other tools. It will be interesting. Also because maybe actually you have to do something over the mesh to make something more stable. But I think they are working on the meshing, so we'll have something better really soon. So the constant force is near to start working, and so now it is falling down. Amazing. Really amazing. I have to say, maybe I'm saying always the same thing, but I have to say that that's amazing. Okay guys, thanks for watching, and we'll see you really soon for more videos from Nyjo FX. Bye!